Hello everyone, Jeff with the Green Review here. While the variability of climate seems random, recent research points to several astronomical and regularly occurring regional climate patterns that strongly influence the always variable climates of the Earth. There are oscillations. The El Niño Southern Oscillation, or ENSO, is probably the best known natural regional pattern of Earth's climate. In addition to El Niño, there are other climate patterns that exert important influences on regional climates around the world. For instance, recent studies highlight the influence of the Pacific Decadal Oscillation and the Arctic Oscillation with the North Atlantic Oscillation in the North American climate. All of these major patterns have characteristic influences in seasonally changing weather patterns of wind, air temperature, and precipitation. Each pattern also has a typical lifetime for any given event. The El Niño Southern Oscillation is typically lasting only 6 to 18 months, while the Pacific Decadal Oscillation can last 20 to 30 years. From both poles to about latitude 45 degrees, the Earth's surface loses more energy to outer space than it absorbs from sunshine. Between 45 degrees north latitude across the equator to 45 degrees south latitude, the Earth absorbs more energy than it loses. This energy imbalance is corrected by the movement of air and ocean currents. In its simplest terms, warm, wet air rises in the tropics and moves towards the poles, while cold, dry air sinks at the poles and moves towards the equator. At the same time, warm ocean currents move away from the equator and cold ocean currents return towards the equator. Every air and ocean current is constantly changing shape and direction in small and large-scale movements. The winds help power the ocean currents. The air and water current can remain stable for long periods, but they can change rapidly in short periods. Study of these changing events has only recently begun, but in some cases, historical records help fill in the gaps in knowledge. Large regions of stable high and low air pressure can remain in place for years and then switch positions across the Earth in a short time. Wind-driven currents can actually reverse direction across the ocean, and massive pools of warm and cool water can switch positions across the ocean. These cycles of events are called oscillations, and they're named for their location, such as the North Atlantic Oscillation and the Arctic Oscillation. Reversals of all three of these events at the same time is the El Niño, La Niña change in the equatorial region of the Pacific Ocean. The switch to the El Niño portion of this oscillation brings rain to the arid west coast and southeast coastal areas of South America, East Africa, and the southern United States. It also causes droughts to otherwise wet climates of Indonesia and Malaysia. It is responsible for dry weather in Southeast Africa and Northeast South America. It brings warm weather to the east coast of China, Northeast North America, and the Pacific coasts of Alaska and Canada. What's all that mean to me? All of the affected areas mentioned in that El Niño Southern Oscillation have climates that are partly shaped by this oscillation. You can't consider the weather or stability of the climates of these areas without considering the El Niño Southern Oscillation. The North Atlantic Oscillation compares high and low pressure systems that influence the weather and climate in North America, Greenland, Europe, and the Mediterranean. From the 1950s until 2000, the cold and warm spells on these continents influenced by the North Atlantic Oscillation coincided with the global warming and cooling trends. The Pacific Decadal Oscillation measures two different atmospheric circulation patterns and changes in the Pacific Ocean surface temperatures. The sea temperatures were warm from 1925 to 1945. The sea temperatures were cool with brief warm spells between 45 and 75, and very warm between 1975 and 1996, and then cool since then. So what's this mean to me? Several types of natural weather phenomena closely match the known global warming and cooling trends. The climate zones on Earth did not change. The range of temperatures within the climates fluctuated warmer or cooler from short-term time frames to decades. The Earth's climates are very complex, and there is a lot of information that still needs to be researched to determine what happens when we have these influences and how they affect the global climate. And this is Jeff with the Green Review. Thanks for watching.